Welcome to Module 203F on cooling systems. Now, if you live in the Medicine Hat area, you know the importance of a good cooling system, and it is an integral part of the heating system. This module has three different objectives that we're going to go through. First, we're going to look at the individual components that make up a cooling system and what their jobs are. And then we're going to look at the operation of a typical cooling system. And lastly, we're going to look at the requirements of putting a cooling system into an existing forced air heating system. Let's look at the components that are used inside a typical system. The electrical side of an air conditioner unit is fairly straightforward. However, it is the understanding how the units work that will allow us to troubleshoot the units when it's necessary. And it's all based on a very simple physics principle. Gases and liquids will get hotter when they're compressed, and the same gases and liquids will lose heat when the pressure decreases. The cooling system consists of two main parts that allow for heat transfer. First, we have an evaporator coil, which absorbs heat from the circulating house air, and then we have the condensing unit that gives its heat up to the outside air. In a standalone unit, such as a window-mounted or rooftop-mounted unit, both of these two components are in the same part. However, in a forced air heating system, then they are in two different locations. The evaporating coil would be found in the upper part of your furnace, and the condensing unit would be a separate unit on the outside of your house. Either way, the refrigeration cycle is the same for both these different types of units. The condensing unit itself also consists of two primary components. The first one being the compressor. The compressor is hermetically sealed and has a driving motor inside it, and it compresses the refrigerant. The input to the compressor is cool, low-pressure vapor, and then it condenses it into a hot, high-pressure vapor on the other side. The other part of the condenser unit is the condenser coils. These are finned radiator that is cooled by air passing through, and it is located where the heat is to be discarded, typically outdoors. The compressor will feed the hot vapor into the coils, and then the vapor cools inside the condenser into a liquid state. However, it is still under pressure. The high-pressure cooled liquid from the condenser coil enters into the refrigerant control valve, which is a thermostatic expansion valve. It uses a temperature-sensing capillary tube and a bulb or a thermistor in order to control how much fluid goes into the control valve. And this controls the amount of refrigerant going into the evaporator coil. The refrigerant is a liquid that easily changes from liquid to vapor and back again. Typically, we would use freon or chlorofluorocarbon gases, or CFCs. Keep in mind these are both bad for the environment, so it is illegal to let them disperse into the air. The refrigerant will have a pressure change happen inside the valve. The high pressure warm refrigerant goes in from the condenser coil, and the low pressure cold refrigerant leaves to the evaporator coil, and the pressure change is a result of the change in pipe size. Cool, low pressure liquid leaving the control valve goes to the evaporator, which is a finned heat absorber mounted in the furnace plenum. The cool, low-pressure refrigerant is cycled through the evaporator coil, and then warm house air is pulled through the evaporator. The evaporating refrigerant absorbs the heat, leaving the air around it much cooler. And now, low-pressure cool liquid becomes warm, low-pressure vapor, which returns to the compressor. Next, we have some auxiliary devices that are also found on typical air conditioning units. We have the filter dryer, which is a combined unit that removes small particles and also removes any unwanted moisture. Next, we have a pressure control, which is a high pressure sensor connected to the discharge side of the compressor and a low pressure sensor connected to the input side of the compressor. We also have an internal temperature sensor, which is a high temperature sensor that will shut down the system if the compressor overheats, and we have a low temperature sensor. The low temperature sensor shuts the system down if it is too cold outside, so the ambient temperature is lower than the evaporator temperature. We have short cycling protection, which stops frequent stop-starts in the system and also protects the system from starting when the pressure is too high. And lastly, we have the crankcase heater, which is only found in some systems. Its job is to keep the compressor crankcase heated so the refrigerant will stay a vapor, and it keeps the refrigerant out of the oil. You have now reached the end of this objective. Review your module, complete the knowledge check, and then continue on to the next video.